Welcome to Module 3, Isometric Projection. My name is Wamkoya S. Bravi. So in our previous topics from Module 1 and Module 2, in Module 1 we covered all about scales, which I already assigned the assignment. You have to do it. We have lines, which was topic 2. And also in Module 2, we tackle about orthographic projection. So in this module, which is Module 3, we are going to undertake isometric projection. So engineering drawings are always drawn in orthographic projection, in which we have already tackled in Module 2. For the presentation of detailed drawings, this system has been found to be far superior to all others. The system has, however, the disadvantage of being very difficult to understand by people not trained in its usage. So we can also talk about true isometric projection in an application of orthographic projection, and is dealt with in a greater detail later in this chapter. The most common form of isometric projection is called convectional isometric. So we can handle a quiz before we continue on our topic. So about convectional drawing, we have as placed the diagram, which is here. As you can see, this is at 90 degrees. The diagram itself is drawn at 30 degrees. So as you can see, it's slanting, which means it was put at 30 degrees, which is located here. We also have here 30 degrees on this line of 180 degrees. So you can see the diagram on how you can handle isometric drawings. There are so many diagrams that you may look about. This one is a hexagonal. As you can see, this part represents the front part, and when you come to this other side, it is representing the plan. You can see how the diagram fits while at the top. So this is all about isometric projection. Isometric projection is whereby a diagram, it's taking the parts, you take the front part, the end part, and the plan. That's how you come to realize about isometric drawings. We can also talk about the circles and curves drawn in isometric projection. As you can see, all the faces of the cube are square. If a cube is drawn in isometric projection, each square side becomes a rhombus. If a circle is drawn on the faces of a cube, the circle will change shape when the cube is drawn in isometric projection. So in isometric projection, you don't just draw the circle. The circle here appears like in a rhombus shape, as an oval shape, but in real sense, it is a circle, because this is where isometric lies, in that it appears, the circle appears slanting. As you can see, it appears slanting. This is because it is drawn in isometric projection. So we can look about a true statement about isometric projection. Isometric projection is a method of drawing with instrument which gives a pictorial view of an object. It is not often used in industry, and when it is, the vast majority of isometric. So as I was just confirming to you, this one was cut in a slanting position, as you can see. This is when you view it in a front part. But when you look at the plan view, you can see the circle is being displayed. This one is another example of isometric projection. This one, as you can see, this one looks at the end view. This one is the front view, and this one here, it's the plan view. Meaning the front part, the plan view is always at the bottom of the front part. So at your side, this one you can see it's a side view, and this one is in a third angle projection because the front part is on the right side. But when the front part will be on this side, whereby the plan will be here and the end elevation will be this side, that one means it is in a first angle projection. So this one will be your assignment. Draw full size and isometric projection of the component shown in figure 1. Looking in the direction of the arrow A, hidden details are not to be shown. So as you can see, this one now is in first angle projection. This one is the front view, this is the side view, and this is the plan view. So I leave at that point so that you may do this exercise for yourself in your notebook. Thank you. Have a good day.